here in the subsurface, and it redeposits that dust back on top of the ice. And gradually, as that ice slowly melts and dissipates during summer, that deposit fades back actually to where it came from and disappears again. And the whole cycle carries on. But what about the bright fans on the surroundings? What about those bright things that were surrounding your fans? Where do those come from? Well, you only have to attend my lectures for Physics 1 to find that out. Mr. Lauterberg, should we do the Physics 1 experiment? We've got a gas bottle for you, filled with CO2. And so we're going to allow this to expand. We have something under pressure, we're going to allow it to expand and see what happens. Buzz, it's all yours. I'm going to come down here and have a good look at this. So, have some CO2 snowballs. Here, why don't you try that? Now, normally, of course, I do not present these things on a plate to the first semester. What I do to the first semester is, of course, that I throw it at them. But I'm not going to do it to you. You're far too dignified. I'm never going to do this. But I am going to throw it at Rudi von Steiger. Oh, sorry. Thank you very much, Jason. But that's the principle behind which these bright fans surrounding our dark fans, that's effectively what's happening. It's an adiabatic expansion of a gas. And in fact, we can model that, and we can model that entire process. And as I've said to you already, the velocities here are enormous. They can go up to anything up to 160 meters per second, and the gas, the amount of gas can be quite huge. Anything up to 1/4 kilogram per second coming out of these vents. So things start to look like that. This, of course, is an artist's impression. I'd love to be sitting down there and taking a look at it. But of course, you like to think we're planetary physicists. We're not only interested in Mars, we're interested in all of the planets. And you ask yourself, well, is there anywhere else in the solar system where this type of process can occur? And the answer is yes. Because on Neptune's moon Triton, the Voyager spacecraft actually saw one of these guys going off. You can see the fans there. But if you look here closely, here you can even see that one of these jets in stereo, we could observe it in stereo and obtain an estimate for how high it goes. You know something? I'd love to do that with a high-rise camera for those jets. And we've tried to do it. And damn it, we've still not managed to do it. So we still don't know how high the things are. But we're going to try again. And in fact, southern summer has just started on Mars 2 weeks ago. And so we're trying really hard to observe one of these things in action. But now, let's come back to our spiders. Get out of here. Who let that guy in here? Let's come back to our spiders. Because I don't know if you noticed it, But the activity that we saw, where those fans originated in some of those pictures, was often on the edges of these spiders. And we always used to think that, well, the center of the spider, that must be where all the action is. But it turns out that it's not. Most of the time, you can see, for example, here, it's at the edges of the spider where things are really getting active. And why is that? Well, we think it's caused by the fact that the topography there implicitly produces a weakness in the CO2 ice slab. And so where you have the ice slab folding over the surface, that's where the ice slab is weakest and where you initialize and where you start this outgassing. And that, of course, allows you to say and allows you to predict, how do spiders grow? Because the gas velocity there is so high, dragging so much dust, it's actually as a result of erosion. These spiders, ladies, are getting bigger. Finally, everything that I've talked to you about there is connected to the southern hemisphere of Mars. But we also see some very bizarre behavior in the northern hemisphere. We see structures like these. This is a dune field in the northern hemisphere. And you can see this very, very weird behavior on the sides of these dunes. Over the past 2 or 3 years, some people have been interpreting this behavior as if it's seepage of liquid water. Woo, liquid water on Mars. But here it's cold. It's real cold. So you can't have liquid water where it's below 200 degrees Kelvin. So what do? Well, you put some impurity in it. In this particular case, perchlorate, which was found by the Phoenix lander. But that's tricky. You've got to get exactly the right 1%. If it's 1.5%, it doesn't work. But I think it's wrong. I think it's wrong because I think the same mechanism that we've just talked about is actually working here. It's just that the sand particles that you have in these dunes here are very much larger, so you don't move them quite so easily. And you know something? I think we've got the evidence that we're right. Here you can see the seepage going on here. You think to yourself, But then it's liquid, right? And you think it's liquid, it's got to stay close to the surface. It's got to sort of dribble down. But have you noticed something? See what that is? That's one of our avalanches again. I don't know how you can get an avalanche with liquid water like that. Very tricky. But we think it's good enough, so we're going to put it in Science magazine. Anyhow, that's basically the end of my story here for today. I've shown you a little bit about David Bowie and his spiders from Mars. And I've shown you a little bit about how they're produced and some of the amazing physics that you can do on the southern polar cap of Mars. I've also shown you there in that last slide about liquid water and how maybe there isn't any there, perhaps. Because liquid water, of course, is very, very important. You know, we're talking here about, is there life on Mars? We still ask this question today. And of course, we've now got the new NASA ESA Mars program that's pushing this forward. But of course, 40 years ago, David Bowie was still asking that question as well. With thanks to Urs, Saliba, and my lovely and wonderful makeup artist. Thank you very much.